All right, you guys, in this section, we're going to be learning how to multiply and divide radical expressions. Okay. All right, so before we begin, let's kind of look over the rules. So in this section, we're only going to be looking at radical expressions that have the same index. Okay, so we don't have to worry about multiplying radical expressions that don't have the same index. Okay, so the steps are going to be like this. So step 1, you're going to multiply the numbers or expressions outside the radical together. Step 2, you're going to multiply the numbers or expressions under the radical sign or radicand together. And then you're going to simplify. So easy and short, multiply the outsides together, multiply the insides, simplify if necessary. Okay. All right, so let's look at a couple of examples. All right, so these examples say to multiply the radical expressions. Okay, so we don't even have to check if our indexes are the same because we already know that they are. We're only going to look at ones that are. So the steps say to multiply the expressions on the outsides together, multiply the expressions under together, and then simplify if necessary. So if we look at this first problem on A, the coefficients on the outside are 1 and 1. So when we multiply the outsides together, 1 times 1 is 1. We keep the square root, and we multiply their radicands together, or the expressions underneath. So 2 times 8, that's 16. And then the directions say to simplify as necessary. So that 1 on the outside, we don't necessarily need to write that. We can drop it. And then we have the square root of 16, which we know is 4. All right. Let's look at B. So B, we have square roots, both of them. The directions say we're going to multiply their outsides together, then what's underneath together, and then we're going to simplify if necessary. So the coefficients on both of these are 1. So once again, we're going to have 1 times 1, which is 1. We're going to keep the square root. And then 3 times 6 is 18. Then we're going to simplify if necessary. So we're going to break down that radical. 18 is not a perfect root. So we're going to come over here, 18. We're going to break it down into primes. 18 is the same thing as 2 times 9. 9 is 3 times 3. Okay. So when we simplify that, because the index is 2, we need to pull out a pair of 3s. And then this 2 here is going to stay on the inside. So when we go to write our answer is 3 on the square root of 2. All right. Let's move on to C. So C, we need to make sure that the indexes are the same. They are. So then if we're multiplying, we're going to multiply the expressions on the outside of the radical together first, then the ones that are underneath, and then simplify if necessary. So the coefficients on all of these are all 1. So 1 times 1 is 1. We're going to keep the cube root, and then we're going to multiply their expressions underneath together. So we have 2 times 16, which is 32. And then 32 times 4 is 128. All right. So we need to break that down, okay? We're going to break 128 into primes. So let's do that over here. So we have the cube root of 128. So when I break that down, 128 is the same thing as 2 times 64. 64 is 2 times 32. 32 is 2 and 16. 16 is 2 and 8. 8 is 2 and 4. And 4 is 2 and 2. Okay? So in order for those numbers to come out of the radical, we've got to pull them out in groups of 3 because that's what the index is. So let's see. I've got a group of 2s there, and a group of 2s here, and then we're left with 2. So we have 2 triplets, and this 2 that's left has to stay on the inside. So when we go to write our final answer, we're going to multiply each one of those groups together. So 2 times 2 is 4 on the cube root of 2. Okay. All right, let's do D. All right, so our indexes are the same. Our directions say that we're going to multiply the expressions on the outsides together first. Then we're going to multiply the expressions underneath together and simplify if necessary. So let's see. We have 2 times 3, which is 6, on the square root of 2, because we need to multiply x times 2x. That's 2x squared. So now we need to simplify. So the 2 that's underneath that radical doesn't simplify any farther. It's already prime, doesn't have any other factors that can be pulled out. But that x squared, so the square root of x squared is x. So that tells us that an x can come out square root of 2. Okay, cool. Let's see if we're right. 4, 3 square root of 2, 4 cube root of 3, 6x squared root of 2. Awesome. We're on a roll. All right, let's try some other problems. Let's try these. So it says multiply the radical expressions. So for A, we've got a monomial times a binomial. So we're going to use the distributive property, okay, when we multiply. So we're going to say square root of 7 times 2 and the square root of 7 times square root of 3. So square root of 7 times 2. So remember, the direction said when you're multiplying radicals, you multiply their outsides together and their insides. So notice that the square root of 7, that 7 is underneath the radical. This 2 doesn't have a radical. So make sure you just don't do 2 times 7 and make it the square root of 14. The 2 needs to remain outside of the radical. So the only number that's outside here is 1. So 1 times 2 is 2. Square root of 7, the 2 doesn't have a radical, so the 7 stays alone, okay? So just make sure you're multiplying the right things with each other, all right? Now let's distribute the square root of 7 times the square root of 3. So you multiply their outsides together first. So what's on the outside of both of those is 1, okay? So we can write it as 1 square root, multiply what's underneath the radicals together. So 7 times 3 is 21. Okay, then we're going to see if anything simplifies. So that 2 on the square root of 7, there's nothing else we can do there, so it has to stay alone. And then 1 on the square root of 21, 21 breaks down, but as 3 times 7, so it doesn't have any pairs, so we can leave it the way that it is. So plus square root of 21. That's our answer. Okay. All right, let's move on to B. So B, we've got the same deal happening again. We've got a monomial times a binomial. So we're going to use the distributive property. So we're going to take square root of 2. We're going to multiply it by 3 square root of 8. So you multiply their outsides together first. So if you need to see it, what's understood to be in front of that square root of 2 is a 1. So we have 1 times 3, which is 3, square root, 2 times 8, which is 16. We're going to take that square root of 2 and we're going to multiply it by negative square root of 10. So we're going to multiply their outsides together first. So this is understood to be a negative 1. So 1 times negative 1 is negative 1. Square root of 2 times 10, which is 20. All right. Then we're going to simplify if necessary. So the square root of 16 is 4. So I can change that to 4 minus square root of 20. Let's see if that breaks down. We have 2 times 10, 2 times 5. It does. So because that's a square root, remember our prime numbers can come out in pairs. So I have a pair of 2's here. This 5 is going to stay underneath. So when I go to write my answer, that's going to be negative 2 square root of 5. And then I can't forget to multiply that 3 and the 4. So my final answer is 12 minus 2 square root of 5. Okay. All right, and let's try this one. C. So we're going to do the same thing. All right, so if you want to try, how about you pause the video here and see if you can get the same answer that I'm going to get. Okay. All right, so I'm going to distribute square root of 5 times the square root of 10, and then distribute square root of 5 times square root of 8. So that's going to give me square root of 50 plus square root of 40. Then I'm going to break both of those radicals down to see if they simplify. So 50 is the same thing as 5 times 10, 5 times 2. 40 is 2 times 20, 2 times 10, 2 times 5. Now, both of those are square roots, so the only way for those numbers to come out is if they can come out in pairs. So for the first one, I have a pair of 5s. The 2 is going to have to stay behind. For the second one, I have a pair of 2s, and this extra 2 and this 5 are going to have to stay behind. So when I write my final answer, I have 5 square root of 2 plus 2 square root. Since the 2 and the 5 are left behind, you can multiply them together. 2 square root of 10. Cool. Let's see if we're right. Yes, yes, yes. Awesome. All right, let's try this set. All right, so before we've tried to multiply singular ones together, then we use the distributive property. Now we've got 2 binomials multiplied by each other. So when we multiply all of these, we're gonna have to use FOIL, okay? So remember, FOIL stands for first, outside, inside, last, okay? So we're gonna use FOIL on these. Let's make that a little better looking. There we go. All right, so let's see if we can do that. Let's change the color. All right, so first we're gonna do square root of 3 times the square root of 6. That's gonna give me square root. 3 times 6 is 18. Outside, square root of 3 times the square root of 3. That's gonna give me the square root of 9. Inside, square root of 5 times square root of 6. That's square root of 30. And square root of 5 times the square root of 3 is square root of 15. All right. Now that we have that, we're going to break those things down, see if we can simplify anything. All right, so let's change the color. All right, so square root of 18. 18 is the same thing as 2 times 9. 9 is 3 times 3. All right, so since those are square roots, the only way that they can come out is if they can come out in pairs. All right, so first, how about I just simplify everything? All right, so let's see, 9 is 3 times 3. 30 is 3 times 10. 2 times 5. 15 is 3 times 5. All right, now let's go and see if we have any pairs. All right, so the first one, we have a pair of 3s. This 2 is going to have to stay behind. The second one, we've got a pair of 3s. The third one, no pairs. Fourth one, no pairs. All right, so our final answer, this first one is going to simplify to 3 square root of 2. The second one is just going to simplify to 3. Square root of 9 is 3. The third one, we're going to have to leave it as the square root of 30 because it didn't break down any farther. So square root of 30. And the last one we're going to have to leave alone. So square root of 15. All right, cool. All right, let's look at the second one. So we're going to use FOIL again. So we have first, 1 times the square root of 5 is square root of 5. 1 times negative 4, that's negative 4. Square root of 7 times square root of 5, that is the square root of 35. And square root of 7 times negative 4, that is negative 4 square root of 7. So remember, if numbers are not underneath a radical, you can't just multiply the 4 and the 7 together. Make sure that the 4 stays on the outside, 7 stays on the inside, okay? All right, we're going to see if anything breaks down. So let's see, 35 is the same thing as, not 3, 5 times 7. No pairs there. Square root of 5 is not a pair. Nope. So nothing breaks down. So that's your final answer for that one. All right. And then now let's look at the second one. The third one. So we've got square root of 2 times square root of 2. That's square root of 4. Square root of 2 times negative 3. That's negative 3 square root of 2. Inside, that's positive 3 square root of 2. And the last one, that's negative 9. So we're going to simplify. All right, so these middle terms actually cancel out. So they're the same, but they're opposite in sign. So we're going to go ahead and cancel those out. All right, the square root of 4 is equal to 2 minus 9, which gives us negative 7. Cool.